Hi everyone, today I brought a nice question from the chapter of alternating current. So the question says that you have an AC circuit like this. This is the input AC voltage whose formula they have given like this. A cos 2 pi ft. This 2 pi f is nothing but omega, right? Angular frequency. And this f is your frequency of the AC source. This A represents the peak value of the input AC voltage, and here we have capacitor and resistor in series. Then we have one more capacitor and resistor in parallel, right? And the output is taken across this parallel combination of C and R. So V0 represents the output voltage here, or you can say here, okay? And the formula for output voltage is given this way. So if you compare the phase, this has phase omega t, this has phase omega t plus phi. So phi represents the phase difference between output voltage and input voltage, right? Now they want graph of phase difference with frequency, meaning how phase difference changes as frequency increases from 0 to infinity. Now mathematically, if you do this problem, it is slightly lengthy and little bit complicated. So we will try to do this without using any maths, but we will just use the understanding that in capacitor, we know current leads voltage by 90°, isn't it? And in resistor, current and voltage are in same phase, right? So using that idea, let us try to see if we can solve this. So we will take some extreme cases when frequency is very small. So when frequency is very small means I am somewhere here, right? So in this graph, frequency when it is very small, phi is positive. Here also phi is positive. Here phase difference is 0. Here phase difference is phi is negative. So let's try to see what happens when frequency is very small. Now when frequency is very small, the reactance of the capacitor, which is 1 by C omega, which is 1 by C into 2 pi f. So when this is 0, this becomes infinity. So reactance has a very high value, and therefore a very small current will flow, isn't it? Because if reactance is infinite, it's like saying it's open circuit, isn't it? But right now we are not we are not saying equal to 0. We are just assuming it is very close to 0. Then what happens? Well, in that case, this will offer a very high reactance. So a very small current would flow, right? A very small current would flow. Extremely small. And here, these two are in parallel. So if this has very high reactance and these two are in parallel, whatever small current comes here will go here only. It will not go here, because this will act like open compared to this. So I0 will go here itself, isn't it? So the output voltage here, the peak value, okay, which is actually given as B. If you look the equation, this is given as B. That will be equal to the peak value of current here into R. Remember, this current is very small, very small. So obviously the voltage here will be extremely small, but we are not worried about the value of that voltage. We are worried about the phase of this voltage. So since at very low frequency this offers too much resistance, you can assume this is not there. It is like open circuit, this part. And therefore all the small current that comes here will go here only. So this voltage will be in same phase as this current, isn't it? So V0 will be in the same phase as current because it is across a resistor. Now this input voltage will be divided across capacitor and these two resistors. But because I told this current is extremely small, the voltage here and here will be very small. So the whole input voltage will be across your capacitor, isn't it? So whatever voltage is across capacitor, the peak voltage, that will be your input voltage also. So since current here is very small, voltage here and here will be almost zero because R is finite. Now here the current, though it is very small, the reactance of this is very high, and voltage across capacitor is what? I naught into Xc. So though this is very small, this is very large. So this product will be a finite value, right? Finite by infinity is 0, isn't it? So this doesn't have to be 0. So this voltage is finite, but these two voltages are tending to 0. Therefore the applied input voltage, peak value, which is actually A, that will be same as peak voltage across capacitor. So now in capacitor we know that current leads voltage. So if current leads voltage, it means voltage across capacitor lags behind current. So voltage across capacitor will lag behind current. But that voltage across capacitor is also your input voltage. So what do we see? At very low frequency, output voltage is ahead of input voltage by 90 degree. And here also they have given output voltage is ahead in phase because this is written as plus phi. So they are assuming in this formula output voltage has more phase than input voltage. And in our answer also we got output voltage has more phase. That means this phi must be positive and it is 90 degree when frequency tends to 0. So this cannot be right because here phase difference is 0. This cannot be right because here phase difference is minus. So either here phase difference is plus, here plus. So either of these two can be right. Now which one? For that we have to analyze the circuit when frequency is very high. So now let's analyze the circuit when frequency is very high. Now when frequency is very high, the capacitive reactance will be very low. So this capacitor will act almost like a short circuit. But since resistance is finite, a finite current will flow this time. Not very small, finite current. And because this has almost zero resistance, or I should say zero reactance, the whole current will flow almost here. So here the current that flows will be approximately 0. So this output voltage V0 will be also very small, but not exactly 0 because we are not saying frequency is equals to infinity, right? So whatever output voltage now you will measure here will be controlled by this current and this reactance. So output voltage will be I0 into Xc. Now I know this is very small because Xc tends to 0. But that's okay because now our voltage is controlled by this capacitor. Okay, because here current is almost 0. So if this current is I0, then voltage output will be same as voltage across this capacitor now, which is behind current by 90 degree, isn't it, for capacitor? And input voltage will be divided here and here, but this voltage is almost 0, I told, because resistance is finite, current is almost 0. So since here the voltage is almost 0, that means this voltage is also almost 0. Therefore the input voltage will be across this voltage, right, across this resistor. So whatever is the voltage here, that will be your input voltage. But this is resistor, and for resistor current and voltage are in same phase. So this will be your V0R. But in this case V0R is approximately your input voltage. So now what did you notice? The output voltage is behind input voltage by 90 degree. So since this is behind, now your phase difference will be minus 90. So phi minus when it happens for large frequency, this option or this option? This option. So this is the right, this is the wrong. Okay. So let's do a quick revision. So when the frequency of the source is very small, tending to 0, these two reactants will be infinite. Therefore, a very small current will flow, very small current, but still some current will flow, right? Because exactly 0 we are not seeing. So some current will still flow, and that small current will divide here. But because this has almost infinite resistance, all that current will go here. The small current will go here only. So the output voltage will be controlled by this current and this resistance, because here there is almost no current going, right? And therefore output voltage and current will be in same phase. And because current is almost 0, this voltage is also almost 0, this voltage is also almost 0, remember, because current is almost 0. Yes, phase it will have, but the magnitude of this voltage is almost 0, very small. That means whatever is the input voltage, that will come here. That means input voltage here will be same as voltage here. That will be equals to peak value I naught into XC. Right? And for capacitor we know current leads, so voltage lags. So input voltage lags. Similarly, when frequency is very high, these two capacitor will act like short circuit. So if you think this is like a short circuit, whatever current flows, now finite current will flow, because this R is finite, this is 0, so 0 plus finite is finite. So current will flow, and that current will divide here, but this has almost 0 resistance, so all the current will flow here. So this will have almost no current. So now the output voltage will be I naught into XC. That means if this is your I naught, output voltage will be like across capacitor, which means it will lag behind current. But still this output voltage is very small, because your capacitive reactance at very high frequency, your capacitive reactance is almost 0. So this output voltage is very small. And because this reactance is also very small, this voltage is also very small. So this voltage is very small, this voltage is very small. So whatever is the input voltage will be across the resistor now. So input voltage will be across the resistor, the peak value. Okay, and for resistor, current and voltage are in same phase, so input voltage will be here. So if you say here phase difference is positive 90, here phase difference will be negative 90. Okay.